Pew Mathematics Paper 2, Wednesday, 14 October 2020. Answer all questions and ensure that your answers to parts of questions are clearly labeled. You should show sufficient working to make your methods clear. Answers without working may not gain full credit. Question number 1. The table below shows corresponding values of x and y for y is equals to square root of x over 1 plus x. The values of y are given to 4 significant figures. Use the trapezium rule with all the values of y in the table to find an estimate for integral from 0.5 to 2.5 square root of x over 1 plus x. Giving your answer to 3 significant figures. Part B. Using your answer to part A, deduce an estimate for integral of 0.5 to 2.5 square root of 9x over 1 plus x. And given that integral from 0.5 to 2.5 square root of 9x over 1 plus x is equals to 4.535 to 4 significant figures, comment on the accuracy of your answer to part B. So we're going to use the trapezium rule formula. I've put the formula at the top there. So we're going to identify the first number y0, y1, y2, y3, y4. And we're going to use the trapezium formula where we would have h divided by 2 and curly brackets y0 plus y4 plus 2 times y1 plus y2 plus y3. y0 is the first term, first value for y. y4 is the last value. So it's the first plus the last plus 2 times the rest. 2 times y1, 2 times y2, 2 times y3. And the value for h is 0.5. And you can get that from the table. 1 minus 0.5 is 0.5. 1.5 minus 1 is 0.5. 2 minus 1.5. Or another way to get h is to use as, if you look at the bottom there, a is 0.5, b is 2.5, and h is given by this formula. So 2.5 minus 0.5 over 4, which gives you 0.5. And when you put h is 0.5 and you sub in the values for y1, y0, y4, y1, y2, y3, it will give you the area is approximately 1.50475. And to 3 significant figure, it will be 1.50. And if you put that in your calculator using the integral, you will get 1.51154. So the answer is slightly different. For part B, we know that the value for 9 then is the difference between what we had the trapezium rule formula to work, well, what we use the trapezium rule formula to work out. So it's square root of 9 times x. So we can take the 9 out and find the square root of 9. Square root of 9 is 3. So you can multiply the previous answer with 3 to get the new value. So 3 times 1.5, it gives you 4.5. And if you use your calculator, you will get 4.5346, which is slightly different from that. And question 1c, the integral of 0.5 to 2.5 square root of 9x over 1 plus x is 4.5. And that 4.5, which is 4.5 to 1 decimal place or 2 significant figure. And the one we are given is 4.535. If we round that to 1 significant figure, to 2 significant figure, or to 1 decimal place, we will get the same 4.5. So to 1 decimal place, or to two significant figures, the answers are the same. And how do we calculate percentage error? You use this formula: approximate value minus exact value divided by exact times 100. And we use this absolute sign because we just want the percentage, not negative values. So 4.535 minus 4.50 divided by 4.535 times 100. That gives us 0.77%. That is accuracy of less than 1%. So the answer is accurate to two significant figure or one decimal place, because to two significant figure or one decimal place, they have the same value. So answer to B is accurate, as 4.535 is 4.50. Relative to a fixed origin, points P, Q, and R have position vectors P, Q, and R respectively. Given that P, Q, and R lie on a straight line, Q lies 1/3 of the way from P to R. Show that Q is equals to 1/3 bracket R plus 2P. So we want to find PQ. PQ is the same as OQ minus OP. The second letter minus the first one. So OQ minus OP, which is Q minus P. PR is equals to OR minus OP. Remember, it's the second letter minus the first. So it's R minus P. And QR is OR minus OQ, which is R minus Q. Now, if you imagine PQR on a straight line, PQ is just one part of it, and QR is two parts. So you can see visually that QR is 2 times PQ, and PR from one end to the other end is the same as 3 times PQ. So if you divide that into 3, 1, 2, 3. So each one is PQ. 3 times that is PR from one end to the other end. Now, we have these two equations. QR is R minus Q is the same as 2PQ, which is 2 bracket Q minus P. PR is R minus P is the same as 3PQ, which is 3 brackets Q minus P. We solve these two equations, 1 and 2. To solve it, you do equation 1 divided by 2. So R minus Q divided by R minus P is equals to equation 1, 2 brackets Q minus P divided by 3 brackets Q minus P. If you notice, Q minus P will cancel. So you're left with 2/3. And if you take R minus P to the right-hand side, it becomes times R minus P. So R minus Q is equals to 2/3 times R minus P. Now, we can take minus Q to the right side, take 2/3 R to the left, and take minus 2/3P to the left. So what you get is Q on its own on the right, and its R plus 2/3 goes to the left, it becomes minus 2/3. Minus 2/3P goes to the left, it becomes plus 2/3P. And what you can see here is R minus 2/3R gives you 1/3R plus 2/3P. You can take 1/3 out of the bracket. You're left with R and you're left with 2P. So Q equals to 1/3 bracket R plus 2P. So these are other ways you can do for question 2. You have the equation 1, equation 2, and you can arrange them like that or like that. And you can do the same, and you follow through and you get the same answer. It's just a different way to arrange and do it. Question number 3. 2 log 4 minus x equals to log bracket x plus 8. Show that x squared minus 9x plus 8 equals to 0. So for question 3a, we start with 2 log bracket 4 minus x equals to log bracket x plus 8, and we want to end with this quadratic. So you know where you start, you know where you want to end. So we're going to use this formula, the power law. Log of x to the k to the base a is equals to the k comes in front, it becomes k log x to the base a. So we want to take this 2 to the front. So it becomes log 4 minus x all squared is equal to log x plus 8. We can take out the logs. We got log on the left and log the legs can come out. Logs can come out. Now we're left with 4 minus x all squared equals to x plus 8. 4 minus x, we write it twice and multiply it out using FOIL, first, outer, inner, last. So 4 times 4, 16. 4 times minus x minus 4x. Minus x times 4 minus 4x. Minus x times minus x plus x squared. And we take plus x to the left, it becomes minus x. Plus 8 to the left, it becomes minus 8. All equals to 0 now. So what you're left with x squared. 4x minus 4x minus 4x minus x. The ones in yellow, they will end up to be minus 9x. And 16 minus 8 will give you 8. So your answer, x squared minus 9x plus 8 equals to 0. Question 3b says, write down the roots of the equation x squared minus 9x plus 8 equals to 0. You can factorize it or you can use a calculator, where a, the number in front of x is 1. The number in front of b is minus 9. The number without x, the constant, is 8. And in the calculator, you get the two answers, 8 and 1. So x equals to 1 or x equals to 8. State which of the roots in BI is not a solution of 2 log x 4 minus x equals to log x plus 8, giving a reason for your answer. What we can do is we can start with x equals to 8. If we substitute 8 there, 4 minus 8, it gives you minus 4. And when you find log of minus 4, you put in the calculator, log of minus 4, it gives you non-real error. That means you cannot find it. So 8 is not a solution, as log of 4 minus 8 cannot be found. So that's your complete answer for question 3a and b. Question number 4. In the binomial expansion of a plus 2x to the power 7, where a is a constant, the coefficient of x to the power 4 is 15,120. Find the value of a. So we want to use the binomial expansion formula. I've got the formula written there at the top. And you can use your calculator or you can use this NCR to simplify. So a plus 2x to the power 7, if we compare it with a plus b to the power n, so that means this a and this a the same. Our b is the 2x. Our n is the 7. Very important. A is the a. B is 2x plus 2x. And n is 7. Now we want to use that binomial expansion formula to sub in. So a plus 2x to the power 7 gives you a to the power 7, which is your a to the n there, plus 7c1, a to the 7 minus 1, times 2x, which is your b, plus 7c2, a to the 7 minus 2, plus 2x squared, plus 7c3, a to the 7 minus 3, times 2x cubed, and then plus 7c4, a to the 7 minus 4, times 2x to the power 4. and that is the one we want, the one I've colored in yellow. So we want to work out that coefficient, and it says that is equals to 15,120. So we find 7C4. To find 7 combination 4, you can use this formula, or you can use your calculator, and then times it by 2 to the 4 times 7 minus 4 gives you a cube times a cube, and that will be equals to 15,120. So all of that will give us, all of this will give us 560. A cube is 15,120. So to find a, we want to find the cube root. To find a, we find the cube root of 15,120 divided by 560. Put down your calculator, you get a to be equals to 3. Question number 5. The curve with equation y is equals to 3 times 2 to the power x meets the curve with equation y equals to 15 minus 2 to the power x plus 1 at the point P. Find using algebra the exact x coordinate of P. So what we want to do is y equals to 3 times 2 to the x meets y equals to 15 minus 2 to the power x plus 1. So that means they are equal. That means y equals to y, and this expression equals to that expression. So 15 minus 2 to the power x plus 1 equals to 3 times 2 to the power x. So we can have, separate this, it will be 2 to the x times 2 to the 1. So after you separate it, you want to take that to the right hand side. It's minus 2 to the x times 2 to the 1. It becomes plus 2 to the x times 2 to the 1 when you take it to the right. So you're left with 15 is equals to 3 times 2 to the x plus 2 to the x times 2 to the 1. We factorize. 2 to the x is common. So we take 2 to the x out of the bracket. We're left with 3 plus 2. 3 plus 2 is 5. It's times 5 now. We take the times 5 to the left. It becomes divide by 5. 15 divided by 5 is 3. And 2 to the x is left on the right. To solve this, we have to take logs. We put log in front on the left and put log on the right. So log 3 is equals is equals to x log 2. The x comes in front, power to the front law, the power law. X comes in front from x log 2. So it's times. You take log 2 to the left, it becomes divided by log 2. So x is equals to log 3 divided by log 2, or log 3 to the base 2. That's how you get the value for x. So x is equals to log 3 divided by log 2, or log 3 to the base 2. Question 6. Given that x squared plus 8x minus 3 over x plus 2 is equals to ax plus b plus c over x plus 2, find the values of the constants a, b, and c. So for question number 6a, we want to get rid of the x plus 2 in the denominator. So we multiply by x plus 2, x plus 2, x plus 2, x plus 2. So the first x plus 2 will cancel in the first fraction. The next one will be ax times x plus 2, and then the next one b times x plus 2, and it will cancel in the last fraction. So you end up with this expression, this equation. So what you want to do now is, on the right hand side, you want to remove the bracket. Ax times x gives you ax squared. Ax times 2 gives you 2ax. B times x will give you bx. B times 2 will give you 2b, and there's a plus c. Now we put the x together. 2a plus b, and x is a common factor, it stays out of the bracket. So we want to compare like terms. 1 is equals to a, that's the coefficient of x squared. A is 1. 2a plus b is equals to 8, that's the coefficient of x, what is in front of x. And 2b plus c is equals to minus 3. So from there, we got a is 1. And substituting a is 1 in there. 2 times 1 plus b equals a. That gives b is 6. And 2b plus c is minus 3. We know b is 6. We substitute 6 in there. And that will give c to be minus 15. So your three numbers are a is 1, b is 6, and c is minus 15. For part B, it says we should integrate that expression. So we start there, and that's where we want to end. Since we had changed it to partial fractions, we know a is 1, b was 6, and c was minus 15 from part A. We can write it out like that. Now we can integrate x. When you integrate x, you get x squared over 2. You add 1 to the power and divide by the new power. 6, when you integrate 6, you get 6x. When you integrate 15 over x plus 2, you can take 15 out of the bracket. It becomes integral of 1 over x plus 2. Integral of 1 over x gives you ln x plus 2, and then there's times 15. So you get 15 times ln x plus 2. And don't forget the minus. Now we need to, there's the limit from 0 to 6. We substitute in 6. 6 will go in there first, and you go there, and you go there. And that gives you 18 plus 36 minus 15 ln 8. After that, 0 will go there, and 0 will go there, and 0 will go there. So you get 0 plus 0 minus 15 ln 2. Now we can remove the bracket. So 18 plus 36 minus 15 ln 8. Minus and minus will become a plus. Plus 15 ln 2. 18 plus 36 gives you 54. 15 ln 2 can come in front. It becomes 15 ln 2 minus 15 ln 8. 15 is common, so you take it out of the bracket to factorize. So you get ln 2 minus ln 8. When you subtract logs, you divide them, so it becomes ln 2 divided by 8. And 2 divided by 8 is 1 over 4. And 1 over 4 is 1 over 2 squared, which is 2 to the minus 2. So the 2 to the minus 2 can come to the front. It becomes minus 2 times 15. It becomes minus 30. So it becomes 54 minus 30 ln 2. So A is 54, B is minus 30. Important part, this part here. Ln of 2 over 8 is ln of 1 over 4, which is the same as ln of 1 over 2 squared, because 2 times 2 is 4. And 1 over 2 squared is the same as 2 to the minus 2 is ln 2 to the minus 2. The minus 2 comes in front, and multiply with the 15 to get minus 30. Question number 7. Figure 1 shows a sketch of the curve C with equation y equals to 4x squared plus x over 2 root x minus 4 ln x. Show that dy over dx is equals to 12x squared plus x minus 16 root x divided by 4x root x. So to do question 7, we want to identify this is where we start and this is where we want to end. So we have y at the start. We want to get dy over dx at the end. So we want to differentiate. We look at what we want to differentiate. I'm going to use the quotient rule to differentiate it. So that's the formula for the quotient rule. And another thing which you need to remember, when you differentiate y equals to ln x, you get 1 over x. So to use the quotient rule, we're going to have 4x squared plus x be equals to u, the numerator, and 2 root x is equals to v, the denominator. So we differentiate u, du over dx, differential of 4x squared, it gives you 8x. Differential of x, it gives you 1. 2 root x, we can write it as 2x to the power half. When you differentiate 2x to the power half, the half comes in front, and you minus 1. So it becomes half times 2x to the minus a half. Half times 2 will give you 1. So it's x to the power minus a half. Now we put that into the formula, the quotient rule formula. So we have v, which is 2x to the half. That goes there, and that's for the v. Du over dx, that's du over dx, which goes next. Minus goes next. U, which is 4x squared plus x, it goes next, times dv over dx, which is x to the power minus a half, all divided by v squared. V is 2x to the half. You put it there and you square it. All we have done is substitute. Now we want to remove the brackets. 2 times 8 gives you 16. X to the half times x to the 1. 1 plus a half gives you 3 over 2. 2x to the half times 1, it gives you 2x to the half. This is like minus 1 times 4x squared. It gives you minus 4x squared. But when you multiply that with the x to the minus a half, so you have minus a half plus 2, it gives you 3 over 2. So it's minus 4x to the 3 over 2. And x times x to the minus a half, this is like x to the 1. 1 minus a half, it gives you a half. So it becomes minus x to the half. All divided by, this would be 2 squared would be 4. X to the half squared is x. X to the half times x to the half. You add the half together, half plus half is 1. So it becomes just x. And what we need to do now is differentiate 4 ln x. We just differentiate ln x and times by 4. When you differentiate ln x, you get 1 over x. So it's 4 times 1 over x. 4 times 1 over x is 4 over x. So minus 4 ln x, when you differentiate, it becomes 4 over x. Now you can put these two fractions together as one. With the common denominator of 4x, you will get 4 times, with the common denominator of 4x, it would get you 12x cubed, 12x to the power 3 over 2 plus x to the 1 over 2 minus 16 over 4x. So now that is our answer, but we want to change it to look like what it says in the question. So what can we do? We want to get 12x squared. What do we times 3 over 2 by to get x squared? If we times by x to the half for all of them, so we will multiply 12x to the 3 over 2 times x to the half plus x to the half times x to the half minus 16 times x to the half over 4x times x to the half. So we times all of them by x to the power half. It keeps everything the same. It hasn't made a big change. So what we're going to do is, when we multiply x to the half times x to the half, half plus half gives you 1. 16 times x to the half, we can just write it as 16 times square root of x. And 4x times x to the half, it will give you 4x to the 3 over 2. Or you can just write 4x and then x to the half. So that is what you would get. And when you add 3 over 2 plus a half, it's like 1.5 plus a half. That gives you 2, which is x squared. So you've got the dy over dx to be 12x squared plus x minus 16 with x over 4x with x. Quod erat demonstratum as required to show. The point P shown in figure 1 is the minimum turning point on C. Show that the x-coordinate of P is a solution of x equals to 4 over 3 minus root x over 12 all to the power 2 over 3. So we have got that expression for dy over dx. So what we do is, if we take 4x root x cross multiply over there times 0, that would be 0. So what we want to do, we want to set the numerator equals to 0 and divide by square root of x. So we have 12x squared plus x minus 16 root x, which is that numerator. If we divide everything by square root of x, divide by square root of x, that will still be 0. What would happen is square root of x can come to the top, it's become x to the minus a half. Comes to the top, x to the minus a half. And this square root of x will cancel. So you're left with 16. 2 minus a half is 3 over 2. 1 minus a half is a half. So you have 12x to the 3 over 2 plus x to the half minus 16 equals to 0. So what we want to do next is to make the term with x to the 3 over 2, this one I've put in yellow, we want to make that the subject of the formula. We want to make this x in yellow, the one I put in yellow, the subject of that formula. So we start by taking minus 16 to the right, it becomes plus 16. We take plus x to the half to the right, it becomes minus x to the power half. It's times 12. We take it to the right, it becomes divide by 12. And 16 divided by 12, you divide by 4, divide by 4, it gives you 4 over 3. So x to the 3 over 2, we just want to get x. So we want to remove 3 over 2. What's the inverse of the power 3 over 2? Is the power 2 over 3. If we have 3 over 2, we take it to the other side, the power will change to 2 over 3. So it will be 4 over 3 minus square root of x over 12 to the power 2 over 3. Question 7c. Use the iteration formula. Find the value of x2 to 5 decimal places and the x coordinate of p to 5 decimal places. So when you want to use the iteration formula, we can start with n is equals to 1. So if 1 goes there for n, 1 plus 1 becomes 2. So we get x2. So x2 would be 4 over 3, stays the same. Square root of n, since n is 1, we want to put x1 there, and x1 is 2. So x1 is 2, which we put square root of 2 divided by 12 to the power 2 over 3. And if you put all of that in your calculator, if you look there, I've taken a screenshot of the calculator. You put that in your calculator all at once. Careful, put the brackets. You get 1.13894 to 5 decimal places. To 5 decimal places. So you round it to 5 decimal places. And the second part of 7 says the x coordinate of p to 5 decimal places. You can deduce that it is 1.15650. And I'll show you on the graph how that works. If you put that equation, 12x to the power 3 over 2 plus x to the half minus 16 equals to 0, that's the equation where we made x the subject in the iterative formula. If you put that in the equation solver in your graphics calculator, so that is your 12x to the power 3 over 2 plus x to the half minus 16 equals to 0, it would give you 1.15650 to 5 decimal places. And that is what you do to show it. So in your graphics calculator, you would go into F3, equation solver, to help you to do that. So that's the first part of question 7a. And this shows completion of 7a and the first part of 7b. And this shows 7c, part 1 and part 2. And this shows how you can use the equation solver to solve that equation. A curve C has equation y equals to f of x. Given that f dash of x is equal to 6x squared plus ax minus 23, where a is a constant, the y-intercept of C is minus 12. X plus 4 is a factor of f of x. Find in simplest form f of x. So we know what f dash of x is. Now to get f of x, we integrate f dash of x. So when you integrate, you get back to the function. So you integrate 6x squared plus ax minus 23. Integration, add 1 to the power, 2 plus 1 will give you 3, and you divide by the 3. So 6x cubed divided by 3. Ax to the power 1, add 1 to the power, it becomes 2, and divide by the 2. And when you differentiate a number on its own, you just add x. And then plus c, the constant of integration. So that's what f of x is. But it tells us that c is minus 12. So we put in minus 12 for c. So we write it out with adding c and minus 12. Now 6 divided by 3, it gives you 2. So we write it out in this simplified form. It also says x plus 4 is a factor of f of x. That means if you put f of minus 4, it will be 0. So what we want to do is we have the 2, we put minus 4 cube plus a half a minus 4 squared minus 23 times minus 4 is equal to 0. And when you do solve that, you get minus 128 plus 8a plus 92 minus 12 equals to 0. So when you solve that, 8a will be equals to 48 and a would be equals to 6. Now you solve in a as 6. So your function f of x is 2x cubed. 6 divided by 2 is 3, 3x squared, minus 23x minus 12. That's what f of x is. So that's your complete answer for question number 8.